Number 4 on page 391. Note that this textbook uses acceleration of gravity as negative 32 feet per second squared. So it says right at the top of the page there, but in case you missed it, we need to use negative 32 feet per second squared as acceleration of gravity. So we've been first given that it's the stone is thrown at 40 feet per second upward. So my initial velocity is 40 feet per second. And it follows the blue arc and hits the ground at 4 seconds. So that means that the height at 4 seconds is equal to 0. And we're trying to find the initial height. Okay, so that's what we're trying to calculate is the initial height. So what we're going to do first is we've been given the velocity, and we're going to start with acceleration. So acceleration is negative 32 feet per second. Okay, so that's going to be a constant. So we're going to integrate this to get the velocity function. So we get the integral of negative 32 dt, and that works out to be negative 32 t plus c. Now, when we plug in our initial velocity, when t is 0, our velocity is 40, our v of t function then works out to be negative 32t plus the 40, which is my initial velocity. Okay, so when t is 0, v is 40. So then I need to come up with my height equation. So the height is equal to the antiderivative. So h of t is equal to the antiderivative function of velocity, which is negative 32t plus 40 dt. And so my h of t function works out to be negative 16 t squared plus 40 t plus, I'm going to call this C2, and the C2 really represents the initial height. So then I need to solve for C2, so I'm going to use the height at 4. So I know that the height is 0 when t equals 4. So I'm going to end up with the C2 as my only unknown in this. So this works out to be 0 equals 16 times 16 is negative 256 plus 160 plus C2. And so I end up with 0 is equal to, looks like negative 96 plus C2. So my initial height, which is C2, is equal to 96 feet. Okay, so then the answer is B.